Okay, so for 3.1 day 2, the difference is the focus isn't graphing, the focus is understanding a graph. Okay? Or creating a function and then maybe graphing it after you've created your function. So that's called modeling, whenever you don't really know the function and you have to figure it out. That's kind of like reverse graphing, you're given the graph. And then you have to create a function. So that's called modeling. The first one I have here is pretty straightforward. It just says find a quadratic function whose vertex is 2, negative 3, and whose y-intercept is 1. Okay? So you don't really need to draw a picture of this. They're giving you h, they're giving you k on a silver platter. Look at that. Can't beat that. Yeah. And when they say that the y-intercept is 1, they really mean that f of x passes through 0, 1 is what it means, right? 0, 1. Okay, so we know that the quadratic function will look like this when we're done with it. A times x minus h squared plus k. That's what it's going to look like. But we're going to have to figure out what a, h, and k are. They gave us h and k, so that's easy. Okay, they gave us h and k, so let's put those in. Put in the h and k. I'll make them green, because they were above there. Okay, and then what you're going to do is understand that if the function passes through 0, 1, then f of 0 is 1. Okay, so this means f of 0 is 1. It's really important you understand that when a graph passes through AB, f of A equals B. Okay, so I'm just going to go ahead and put 1 on the left, and x is 0. And solving this gives you actually A equals 1, turns out. So let's just add the 3 over. So this is 4 equals 4a. A is 1. Okay, so we actually do know our function entirely. It's f of x equals 1 times x minus 2 squared minus 3. And there's your function. This is a model. Okay, so that's your first one. The second one is pretty much the same problem, except it's going to be the x-intercept that's 1. Find a quadratic function whose vertex is 2, negative 3, and whose x-intercept is 1. So we can still start off by doing f of x equals a times x minus 2 squared minus 3. But we're going to interpret x-intercept is 1 to mean f of x passes through what?
1, 0.
Yes, 1, 0. In other words, f of 1 is 0, not f of 0 is 1, so it's just reversed. That just means the left side would be 0 when x is 1. Okay, so 0 is a minus 3, and therefore a is 3. Okay, so your final function is f of x equals 3 times x minus 2 squared minus 3. Very similar to the last problem, I just switched things up a little bit. Okay, and then the next problem is a little more cryptic, so it takes a few extra steps, you know. Everyone got the example 2 there? Alright, on this one it says find the maximum value of the function whose x-intercepts are negative 1 and 7 if the y-intercept is 3. Okay, so I'm going to draw a picture of that real quick. They're saying that the x-intercepts are negative 1 and 7. The That makes sense. Lots of parabolas have two intercepts, two x-intercepts. And I'm going to understand that this means the point -1, 0, not just -1, you know. And this is the point 7, 0. So try to interpret your intercepts as coordinate pairs. Let's put the phones away, guys. Okay, and then they said the y-intercept is 3, so that would be this point. I'm going to write that as 0, 3. And if this is a parabola, I believe it has to open downward, right? So it kind of makes sense if the graph looks like this. It would not make sense for this parabola to open upwards at all. Okay, is everyone with me so far? Okay, before I go on to calculate any f of x equals blah, 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 I think there's one more thing I know. Yes?
That the axis of symmetry is that x is equal to 3.
You're right. Why?
Because it's equidistant from the x-intercepts, from both x-intercepts.
Correct. If you gave this picture to a 4th grader and said, find the line of symmetry, they would probably nail it. They'd draw a line right down the middle. Right? And they would assume that it's halfway between the -1 and the 7. That is very good reasoning. So that's not true on all functions, but it's true on a parabola. Good. So we know that mathematically we can find the middle, which would be the h value, by just averaging the -1 and the 7. This is how you find the halfway spot between two numbers, right? So you're right. At x equals 3, that's where our line of symmetry is. At x equals h equals 3. Okay? Good. Halfway between the intercepts. And then that's like the last clue you needed to kind of get the ball rolling. So I'm going to write this vertex up here. It's 3, k. Now what am I trying to find in this problem? The maximum value. That means the maximum output value. Okay? They want k. That's what this question is actually asking for. This means find k. The function has many y values, but I want the highest one. That's what it means. Okay, now we kind of have our bearings, and we can set up our function as best we can. It looks like f of x is going to have to be a times x minus 3 squared plus k, and I do not know k yet, and I don't know a yet, but I have a lot of clues. All these points that I know are opportunities for me to plug in numbers. Okay, for example, here I can plug in x equals -1 and just assume that y will be 0, and I can plug those in. And then I can plug in 0 and 3, you know. So we're going to have to find two different variables, so that means we're going to probably need to probably substitute two of these green points into this thing. Okay? We'll just do one at a time, of course. Yeah?
Wouldn't k equal 3 because 3 is the y-intercept and the y-intercept is equal to c?
No, it doesn't.
Oh, let's just talk about that real quick. When you see something like this, yeah, I was going to say this today anyway, because I know this might mess people up. Some people look at this, look at the top there in purple, they'll say, oh, the y-intercept's 4. That's true. But they'll also look at this, oops, I meant to have my square on the outside here. They'll look at this problem and they'll say, oh, the y-intercept is 4. That is not true anymore. When you're in standard form, this is called k, not c, right? And it's not this y-intercept anymore. So in the first function in purple at the top, c is 4. That's actually the y-intercept. But in the standard form, don't be deceived. That 4 is not the y-intercept. It's the y-coordinate of the vertex. So if you want to find the y-intercept of this one, you have to make x 0, and you actually get 200 plus 4. See? Because that's going to be 0, and you get 100 there, and 200 plus 4. So, yeah.
Then isn't k just c plus the unfactored form of the,
Yeah.
the internet digit plus the last
Sure.
digit of your vector?
Yeah, you could use that
You
logic.
also have to know what a is.
It will affect that, because everything's under the influence of A. So.
Here,
I was going to mention that anyway today, so I'm glad you asked that question. We don't want to assume that the constant in every problem is our y-intercept. Okay? Or even think of it as an upshift. It's not always the upshift. Okay, so let's go ahead and take these green points and plug them into this function down here. So why don't we use -1, 0 first. So that means you're going to make the left side 0, and you're going to make x -1. This just gives me that 0 equals 16a plus k. I'm going to hang on to that. I don't really know what to do with it right now, but I'm sure it's important, all right? Now let's try using... Now I don't think I'd use the other x-intercept, okay? We've already used one of the x-intercepts. I think if you use the other x-intercept, what's going to happen is you're going to get 0 equals 16a plus k all over again. Why don't we use the y-intercept? Okay, so let's do that. So let's use 0, 3. So the left side is 3, and then this is equals a times 0 minus 3 squared plus k. Okay? And this gives us the statement 3 equals 9a plus k. And armed with these two statements, I can solve. Right? Substitution will work great. So this first one, I'm going to go ahead and isolate and get that k is -16a. Just, you know, subtract 16a. Substitute that into the second equation. This will just be 3 equals 9a minus 16a. So a is -3/7. And since k is just -16a, I can assume that k is -16 times -3/7. So the answer is 48/7. It's awkward, but that's the answer. The reason we're getting an awkward k value is because the intercepts were so nice and clean. I gave you such nice, neat intercepts, oftentimes something will give and come out messy. So it turns out it's the k value this time. Okay, it's hard to have perfect A, H, and K on the problem. So nice numbers for some things. That's what, almost 7? Very close to 7. Yeah, so you can see now what that means. That's the y-coordinate of your vertex. So you can go back to your picture if you want. Now you can sort of update this. I'll scroll back down in a second. You can say, oh, okay, well this is at 48/7. And that makes sense. That's reasonable. If you got 487, something's wrong, right? Doesn't seem to fit the picture. But know that maximum value does mean k on a parabola problem. That'd be like an advanced SAT problem too. I've seen them about that hard on the SAT. But for parabola problems, that's about as hard as it gets on the SAT. Okay, let's talk about a word problem real quick. Let's say there's a guy, Ted, and he wants to build a rectangular dog pen so his dog can run around. So he goes down to the store and he buys some fence, 100 feet of fence, 100 feet. Okay? And, you know, he could take this and form it into like a square. That actually does give you the most area for your rectangle. So you could go like this and do 25 on each side. He could do that. That's 25, 25, 25, 25. That's 100 feet. And he would get a playpen for the dog with an area of 625 square feet. Okay? But he's smart. He has a barn at home. And so he knows that he can use the barn instead as one of the sides and make a bigger pen for his dog. So that's pretty smart. So he's got a barn. Most barns are red, although they look better than mine. He's going to build his fence like this. Instead, that way he can use the barn as one side and he'll be able to make a bigger playpen for his dog. Okay, so what we don't know is the dimensions of this playpen. All we know is that this is some unknown amount, we'll call it x, and that this, of course, would be the same amount. So I'm calling both of those x. And we know that he bought 100 feet of green fence. So he's used up X on one side, he's used up X on another side. How much fence does he have left? 100 minus 2X. Okay, now I'm trying to find the maximum area of this dog pen. So it might be helpful to write down the area of the dog pen at some point. I think this is a good time. What is the area of this rectangle? Think of it two-dimensionally, not three-dimensionally. I'll draw it from top view. Here's the barn. These are both X's. This is 100 minus 2X. I just want the area of the dog pen. Yeah, you can just multiply length and width, right? Length and width. It doesn't matter that one of the sides is red. The area is still X times 100 minus 2X. Okay, so the area is X times 100 minus 2X. Okay, there's a lot of ways to proceed from here. Let's just keep it in the vein of what we've been doing. We would write this out in general form, negative 2x squared plus 100x. Okay, we would then be probably interested in the vertex. Most of the time when you're given a parabola like this, you'd be interested in the vertex, right? Yeah. So let's go ahead and factor out that negative 2. I'm going to write it as a of x. Looks cool. So I'm going to pull out a negative 2, just like I did in the warm-up. And this gives me x squared minus 50x. There's no third term, but I can still complete the square. So I'm going to go ahead and add in, what's the magic number here? Yeah, half of 50 is 25. Square that. So 625 gets squeezed in here. And I just put in a brand new 625 that's under the influence of a negative 2. So I just decreased the function by 1250. I need to add 1250 to keep it balanced. Add 1250. Okay, so here is our area function. Watch close. Negative 2 times x minus 25 squared plus 1250 is how it all factors out. What does it mean? Well, it means the vertex is where? Where's the vertex? Look at the standard form. 25, comma, 1250. 25 is the optimum x for this guy to build his playpen at. So we have the barn, and we've determined now that when this is 25, and of course this is 25, and if he uses the rest of the fence for this vertical side, this gives him the most possible area. So he knows now that 25 is the best length for x. We call that the optimal length. Okay, so basically it works like this. If x equals 25, the playpen has the largest possible area. That area, I'll just write it as two sentences. The maximum area is what? 1,250 square feet. So this standard form is suddenly very meaningful. The h value represents the perfect width of a dog pin, and the k value tells you the area of that dog pin. See? So that's very meaningful. And they have different units, right? The 25 is feet. Let's put that in. I forgot to write that. And the maximum area is feet squared, obviously. Okay, any questions on that? All right. And then the last problem is this money problem here, except it's, there it is. This actually is very similar, except it's not a dog running around and frolicking in a rectangular space. This is more of a finance problem. We're going to talk about revenue and how revenue is price times quantity sold. Price times quantity sold. Okay, so you can just write down one letter at a time here. You don't have to write the whole question right now. Just write the price P and the quantity X sold of a product. Obey the equation P of X equals negative 1/2 X plus 20. Okay, and then there's this little 0 is less than X is less than 40. What's this? This is just common sense, okay? You cannot have negative numbers of boxes. So we have to keep X greater than or equal to 0. You can have 0 boxes or 5 boxes, okay? Also, you can't have a negative price. So the reason I stopped at 40 here is because if you plug in 40 into this function, you get a price of 0. If you go past that, you get negative prices. It doesn't make any sense. So what I'm saying is this graph of P of X has a Y-intercept of 20. Let's make this 20 up here. And it has a slope of negative 1/2, which means it comes all the way out here and it hits the x-axis at 40, see? And it doesn't make sense to talk about any other x's because x means the numbers of boxes, and it doesn't make any sense to have negative number of boxes, nor does it make sense to have boxes beyond 40 where the price suddenly becomes negative. So this is just the most meaningful part of the graph. That's all this means. Don't let this kind of stuff intimidate you. They're just giving you some meaningful constraints for x. Okay? Let's write down the revenue function. Maybe you don't know what revenue is. Well, it's given in our book, because our book knows you don't know that stuff. It says right there, R of x is x times P of x. So let's just take it very literally. R of x is x times P of x. Okay, whatever that means, right? You'll find out in econ class maybe someday, right? Okay, well, P of x was negative 1/2 x plus 20. So I guess R of x is negative 1/2 x squared plus 20x. Okay, what is the revenue if 8 units are sold? That's simple. They're just saying if x equals 8, what is R? That's all it's asking. You've got a function. So even if you don't know the money theory or whatever, just plug it in. When there are 8 units, it'll be negative 1/2 times 8 squared plus 20 times 8, which is negative 32 plus 160. It looks like 128. And it's revenue, so that's the end of that one. What quantity X maximizes the revenue? Sounds like a vertex question to me. Right? Just like the area of the dog pen. Okay, so we're going to find the vertex of R of X. Anytime a maximum is mentioned, you could probably just think vertex in a quadratic situation, right? Okay, so let's put our R of X in standard form. It was negative 1/2 x squared plus 20x, and I'm going to factor out that negative 1/2. Okay, and I'm also going to add in the magic number, which in this case is 20 squared, 400. Don't forget to keep it balanced. You'll need a plus 200 out here. Okay, so it looks like R of X factors into negative 1/2 x minus 20 squared plus 200. So what value of X maximizes the revenue? 20. 20. What is the maximum revenue? 200. The answer to these two questions are just the coordinates of the vertex, H and K, respectively. What price should the company charge to maximize their revenue? 20. Actually, no, price when X is 20. So what is the price when X is 20? They should charge $10 and they'll maximize the revenue. You can just model your work for the finance problem after mine. It's going to be basically copy and paste. It's the same thing.